Welcome or welcome back. Today we're going to be talking about chain rule. So chain rule is used to take the derivative of a composite function. So what a composite function is it's a function inside of a function. So with a composite function, which you can see here, we have an inner function and an outer function. So in this example, the outer function is f and the inner function is g. So outer function, inner function, and that's how I'll be referring to them throughout the video. This is not the same as a function times a function. So a composite function is a function inside of a function, and a lot of times students confuse this with two functions being multiplied together, and this is not the same. So for example, when I'm looking at a trig function like sine, this is sine of x squared. So the x squared is inside of the sine function. This is not, that first chunk is not saying sine times x squared. This is sine of x squared, whereas the example on the right is sine x times x squared. So the first one is a composite function, and the next one there is two functions multiplied together. So for the first one, for a composite function, we use chain rule. For the second one, for two functions multiplied together, we use product rule. So that's a big one we don't want to get confused. Chain rule, product rule, two very different things. All right, so once again, we have our outer function and our inner function. So when I take a derivative, I do derivative of the outer function. Inner function stays the same times the derivative of the inner function. So once again, derivative of outside function, inside function stays the same times the derivative of the inner function. I literally say that to myself when I'm taking a derivative, like an inner monologue. Keep cueing yourself. Outer function derivative, inside stays the same, times the derivative of the inside. That's an important one to remember. I always want to keep asking myself, do I need to multiply by the derivative of the inside? That's something a lot of students forget to do, and that's a very important part of chain rule. So here it is again, chain rule. Derivative of the outside, inside stays the same, times the derivative of the inside. We can also do a double chain rule. So now I have a function inside a function inside of a function. So when I take this derivative, once again, derivative of the outside function, inside stays the same. Even though the inside is a composite function, fine, stays the same, times the derivative of the inside. So derivative of the inside is going to be one more iteration of chain rule. So I got f prime, inside stays the same, g of x stays the same, times the derivative of the inside again, which will be g prime of x. So I have the first chain rule there with the inside being f of g of x, and that whole chunk at the end is times the derivative of the inside. But within that derivative, I have an additional outer and inner function, which is why this is a double chain rule situation. You can have functions inside of functions, as many as you want. Sometimes there's a lot. So that's why I keep reminding myself times the derivative of the inside so I don't forget to do a chain rule if there's more than one involved. All right, let's look at a quick couple examples. The first one here is cotangent of x squared. So this is a composite function. The outer function is the cotangent function. The inner function is my x squared. So that's my outside and my inside there. When I go ahead and take a derivative, I'm going to do derivative of the outside. So I do derivative of cotangent, which is negative cosecant squared. Again, inside stays the same, so x squared stays the same. Times the derivative of the inside will be times the derivative of x squared, which happens to be 2x. So that is just showing each of those pieces in gory detail. So hopefully you can keep up with what's going on, no problem. And then for my last step, I'm just going to rewrite it. I like to put the negative 2x in the front. I just think it looks nicer, not necessarily necessary, but I'm just going ahead and rewriting it there. And that's my final answer. Next, we're going to look at a square root function. So when I see a function with a square root or any power really, I like to go ahead and rewrite that very clearly for myself so I know I'm taking power rule. So I go ahead and write it to the 1/2 power, and that's actually my outer function. That 1/2 power is going to be my outer function, and I will take a derivative of that using power rule. Then the inner function is the x plus 1 over x minus 5. So when I take a derivative of that, when I'm doing that portion of chain rule, I will have to use the quotient rule. So we'll go ahead and take a derivative here. Derivative of the outside power rule, drop down the 1/2 power, chain rule. Inside stays the same. Power rule, I got that 1/2 minus 1. We'll put it now to the negative 1/2 power times the derivative of the inside. This is quotient rule. Bottom, d top, derivative of the top is 1, minus top, d bottom, derivative of the bottom is 1, all over the bottom, which is x minus 5 squared. And that's coming from quotient rule. And this is just showing which functions are inside and outside. All right, so now I'm going to go ahead and clean it up a little. Instead of negative 1/2, I have positive 1/2, which I'm changing back to that square root here. And all I have to do is flip flop the middle. So now the x minus 5 is on top and the x plus 1 is on the bottom. And I'm going to go ahead and distribute the negative to that second portion of the top. So I've distributed that negative 1 on top, and we're going to go ahead and clean it up again. The first piece will stay the same. I have in that fraction over there, x minus x, so those will cancel out. And all I'm left with is negative 5 minus 1, which gives me a negative 6 on top. The bottom will stay the same, x minus 5 squared. And now I can go ahead and cancel the 2 down there with the 3 on top. And so for my final answer, I'm left with that radical, which will stay the same, and then the fraction, which will now be negative 3 on top and x minus 5 squared on the bottom. And that's what I'm going to leave as my final answer. Could you clean it up a little more? Maybe, but I think it's good the way it is. We'll leave that whole radical together. All right, next up, we have another power rule situation. So again, I like to rewrite these. I want the power to be on the outside to make it easier for me to see the power rule and who's inner and who's outer. So I put the square outside of the entire function. So now power rule, drop down the 2. Inside stays the same. So that whole term will stay exactly the same. And then this will be to the 1 power from 2 minus 1. Now chain rule times the derivative of the inside. Derivative of sine is cosine. Chain rule again, inside stays the same. 4x plus e stays the same. Times the derivative of the inside. Now this is the derivative of the 4x plus e, which will just be 4 plus 0. E is a constant, so its derivative is 0. I know that one's a little tricky. So now I'm going to multiply the 4 and the 2. I like to put the constants in front. I think it looks nicer. I no longer need to write that 1 is the power up there. It's a little redundant. And everything else I'm just going to rewrite. And that's my final answer. So that one was pretty quick and painless, right? Plugging right along, another power rule. I don't know why I picked so many power rule examples, but here we are. So dropping down the 7, inside stays the same. That power will be 7 minus 1, which is going to be 6 to the 6th power there, times the derivative of the inside. Derivative of 3x squared will be 6x plus derivative of 2x is 2. One final step, you don't have to do this, but I thought it looked nicer to have 2 terms instead of 3. So I multiplied that 7 into the last term there to get 42x plus 14. And then I'm just going to leave this to the 6th power. Nothing could possess us to want to multiply that out. So this is my final answer for that one. Here we have a natural log function. Those are kind of fun. So for natural log, derivative is 1 over inside. So for chain rule, inside stays the same. So I'm going to have 1 over the whole inside, which is cosecant x squared. Now for chain rule, I do times the derivative of the inside. Derivative of cosecant is negative cosecant cotangent. And the inside here will stay the same. We got another double chain rule. The inside x squared stays the same, and I have to once again multiply by the derivative of the inside, which here will be 2x coming from the derivative of x squared. So now I'm going to go ahead and take everything into one fraction, everybody on top and then everyone on bottom. So on top, negative 2x cosecant x squared cotangent x squared. And on the bottom of this fraction, all I have is cosecant x squared. Now, as you can see, one of our favorite things to do, we can cancel. So go ahead and get rid of that cosecant x squared. And all I'm left for my final answer is negative 2x cotangent x squared. So that one was pretty satisfying, not gonna lie. All right, last but not least, we went a little out of order, but that's okay. I have another trig one, and this is another double chain rule. We're going out with a bang. So derivative of sine is cosine, inside stays the same. So that sine of sine x will all stay the same. Times the derivative of the inside, cosine, sine x stays the same. Times the derivative of the inside, cosine x. And now we're finally done. So that's a lot of times the derivative of the inside. That's why I keep asking myself, times the derivative of the inside. Does the inside actually have a derivative that I need to multiply by? If the derivative is 1, you're done. If it's not, we need to keep making sure we do chain rule. So for this last one, I'm just rewriting it without the dots. Really, there's not much here that we can do to make it look any cleaner. It's just kind of long and kind of crazy, but what can you do, right? If you found this video helpful, please give it a like. If there's something specific you'd like me to do in a video or a short, any topics or problems that you'd like me to do, please let me know in the comments. I would genuinely love to hear from you. If you're not already, please subscribe. And if you need one-on-one tutoring, if you'd like a little more help, nothing wrong with that, please check out my website, which is stemtutoring.net. Thank you so much for watching. I'll see you in the next one. Bye.